wanted to start out with a new project to show just a minimal project downloading in the user interface here. So we're going to call this empty project. And I'm choosing today the serial touchpad with USB for downloading, and this one also features the 8 megabytes of onboard flash. And I'm going to make this smaller here so that you can see also physically. All right, so all I did was create a new project. I went to this drawing area which has static objects that appear on your screen, created an ellipse, and now I'm going to run and download project now. Let's restart the ICP so that we can see it. Okay, you can see that it arrived, although you didn't get to see it arrive. Let's repeat that. I'm shutting off the touchpad. We have the switch on the back set to position 9, so that when it comes up, it's waiting to receive an operating system update or a new program. So all I'm going to do now is, and it's this equivalent of running, pushing F9, is build and download. So we'll do that again, and you can watch it load. Okay, so there's the program. Now here we have a portrait program running, and we're viewing it in a landscape orientation. Now let's create one that actually does something. This one is going to operate the machine that you see right here that the touchpad is sitting on. This is one of our I/O modules. And if you look here, these little LEDs are going to be going on and off. So this time I'm going to make it land that we match the orientation of our picture. And each screen on a program needs to be either ladder or C. And we're going to make this ladder logic. Yes, we're going to save the old project, even though it doesn't really do anything. Okay, so here's a new project. Let's create a connection. All connections on this device are serial.
Hey.
And we're going to be a Modbus master. Let's go on. Now that we've created a connection at 9600 baud, that's the default baud rate for modules like these. This is a serial I/O module. Now let's add the device. It's one of our i7000 series. We choose the connection, and we're going to select the correct model here. This will automatically create tags. If you had a third-party Modbus RTU device, we would be doing this a little bit differently, and you would have to enter the tags manually yourself. So now you see that we have all these tags automatically created because there's a file that lists what these are, and you can also create these files on your own for third-party devices. So let's click OK. The model, the device name is i7061. Now, let's go back to our toolbox. Now, these drawing items here are static. Widget items are dynamic. They can change at runtime. And I'm going to use a checkbox. I'm going to put it some arbitrary place on the screen. I'm going to associate it with a tag that was already created. And here's one of the digital output tags. So now the operation of this checkbox is associated with the tag. Now, it's not very good looking yet, but let's see how it functions as it is. I'm going to push F9 so that we are creating the project. Now, what I forgot to do was turn off the machine. Now the machine is off and back on. And you can see that it's waiting for download. So I'm going to push F9 and we're going to start the download. Now you see literally the same thing. Watch these buttons underneath. See the light there? And this is the relay module. You'd also hear the relays clicking if you could pick it up through the phone, which you won't. Now let's make this application look a little bit better. Checkboxes can be associated with various different images, even including custom images. To do this, we're going to go to create one of these system objects. An object list is going to be a little reference of different images that we want to show on our checkbox. So we come over here, click the Library tab, and we can look at some of these buttons. Big manual button 0 and 1. We need a pair of images, one for on and one for off. So you can see down here we're previewing our images. So we pick the Big Mag 0, and we don't want arrow category, we want button category. Notice that there was a category drop down up here. Now this list of images now has those two images that we previewed in there, and so you can see which they are here. Now, that still does not associate any image to this checkbox. We need to do that. So we're going to select the checkbox, and we're going to go to our reference object area, and we're going to use this object list that we just created. Object list number 5, and we want to have the size more appropriate for the button. So let's see how this one looks. I'm going to turn off the power to the touchpad, turn it back on, and again, because the switch is in position 9 on the rear, it's going to go into this loading mode. I'm going to push F9, the development environment, and there you have the image showing. Let's see if I can hold it for a little bit better viewing there. So you can see that it's very easy to create simple programs with your ladder. Now let's have another output that is based on some timing. Go back to the workspace, and we're going to go and see the actual ladder area. Let's create a function block. Now we have a function block here and an output coil there. Let's go pick a timer. Let's assign a delay, milliseconds here. Now it's looking for tags, but we're going to go to this other category constant. You're going to enter 10,000 milliseconds, 10 seconds, in other words. Now, we need to associate this coil with a tag. We've already used DO channel 0, so let's use DO channel 1. And so it shows up there. Now, I haven't found in the manual where it shows how to change coil types, but the key is to just click the space bar and you go through the different coil types that are available. And we're just going to pick the plain type one-to-one logic with the value coming out of our function block. So let's do save and close. Now, we don't have anything visual associated with that. Let's go ahead and download. First of all, turn off the power, turn back on the power. So now let's hit F9. Now watch down here. The program has started, and we're waiting for that 10-second timer to time out. There it goes. So that's where the ladder created an action, right there. Let's modify our program a little bit. That's all we need in this case. Now we're going to take this value here and repeat it as an input. Here we're going to have the output. But we're going to make this an inverting contact. So that's an easy way of doing a not. Let's see what that does. Push F9 to download. Notice how one light is already on. This is the knotted one. And in 10 seconds, we should see the two invert. There it goes. It moved from one to the other. All right, let's go on to some C programming. Again, we're going to use landscape, but this time we're going to do a standard C program. All right. Now, one of the things that you want to do in C is see numbers come up on your screen. So let's go to our toolbox, go to widgets, the active images that you can change at runtime, and put a label here. Let's go to use a timer here. Notice this is different from the function block timer. All right, now this is decoding. We can declare globals up here. Down in here, we're going to put the code that changes that label. And one thing you can do is run multiple instances of the development environment at the same time. This is very useful for when you're working from demos. Very often you'll find that you're deriving your new program from one of our existing demonstration programs. I believe this one has an example of what it has to do here. Here we have an output area, and there's, in this case, this is A. This is a button here. So double-clicking any of these objects brings us into the code for the handler. And what we wanted is the code that creates an output. So I'm going to copy this code here, jump back over to the other application, paste the line of code in there. And we're also going to declare a static array. Static is necessary for our strings because when you set this text, it's not yet displayed. So it doesn't do a copy of the string. It just remembers the pointer. So the pointer has to remain valid for later actions. Now here's our string name here, and useprintf is the equivalent of sprintf. For those of you who are familiar with programming, you'll recognize that function. This is for the Stellaris microcontroller that's inside. Now, write success is not what we want to be viewing. We want to look at count. And we have conversion to decimal here. And we are creating a formatted string. Now we're going to go for label widget. This is from the other program, label widget 6. So let's go and see what our label ID is. Right there it says 4, and you can verify that up here. If you copy and paste these, they're all going to say label 4, but up here it's always going to show your correct ID. So let's go back into our code by clicking something that has an event. And so it's going to be label widget 4, and it's outstring. And here we're actually telling it to paint the widget. So again, it's 4. Now that's going to paint the same number every time, and we don't want that. We want a number that's increasing. So each time the timer runs, we're going to increment it. Let's try just compiling first. Instead of that F9, I'm going to push F5. And we have an error. Let's see what we have. Oh, an earlier version used label widget 4. Now we're just using label 4. So the type of the object, the name of the type of the object changed a bit. Let's try compiling again. So we compiled with no errors. So let's go back and download now. And there you can see the screen again. Off and on. Now let's push F9. You get this hand icon here and it blocks actions. Go over here, hit escape. And now you can select things again. And now that this window is active, we can push F9 and have it work. Now, you can barely see that here. The number is incrementing. Let's make it look a little bit better here. For the label, let's just select a large font. And let's try changing some colors a little bit. Now the frame will have that color when we actually run it. Power off, power on, compile and download. So now those numbers should be large enough that you can actually see them running. Suppose we didn't want to view this box. There's a lot of aesthetics that you're going to want in your final product. We have a black outline color, all zeros, all dark. Let's pick out that same green. I believe it was this one. FF80, let's check here. Yes, same color. We still want the fill color of the numerals to be black. Now, pardon me, this is white. This is the background color. We want the background color like this. Now, unlike the screen, this one does show up online. So let's power off and on. So now we got rid of that box, and it doesn't look like something that we want to select or that users would try and create an input to, which they can't anyways because there's no keyboard on this. Keyboards are implemented as groups of buttons. Let's see if I can find an application that shows you the keyboard. Here's where you can see the different pages that come up. These tabs here down at the bottom enable us to go to different pages that will be accessed. Now, I didn't find the keyboard for you, so let's look at this demo and see how some of the things are implemented. This one has been implemented in Ladder. This is how we saw the images. I think that's about all we've got for now. There we go. If you want a keyboard, you can copy this one as an example, create a new project, we're going to maintain the same orientation, but we're going to U in this case. The USB type, we're staying with C, and we're going to call it keyboard target. And there you have your keyboard. So this is one way you can use the demos to help speed your development process. Now, let's look at the handler here for an example. Bit button 80 on click, pointer to widget. There's not a separate handler for each button here. They can all use a common handler. Notice that the on click, we've specified the same routine in each one. in our target program, we're going to have to copy and paste those codes. But in here, you're going to find that wherever widget is, there's a way to get the tag property, and that will identify which button we have. This one has text 7, tag 0. Okay, in this case, we're looking for the text in our handler. So that's all for today, and if you have any questions, feel free to email me at this address. All right, thank you everybody for attending.